Helium, from Greek, lambda iota omicron sigma, Romanized, helios, lit. Sun, is a chemical element with the symbol He and atomic number 2. It is a colorless, odorless, tasteless, non-toxic, inert, monatomic gas and the first in the noble gas group in the periodic table. Its boiling point is the lowest among all the elements, and it does not have a melting point at standard pressure. It is the second lightest and second most abundant element in the observable universe, after hydrogen. It is present at about 24% of the total elemental mass, which is more than 12 times the mass of all the heavier elements combined. Its abundance is similar to this in both the Sun and in Jupiter, due to the very high nuclear binding energy, per nucleon, of helium-4, with respect to the next three elements after helium. This helium-4 binding energy also accounts for why it is a product of both nuclear fusion and radioactive decay. The most common isotope of helium in the universe is helium-4, the vast majority of which was formed during the Big Bang. Large amounts of new helium are created by nuclear fusion of hydrogen in stars. Helium was first detected as an unknown, yellow spectral line signature in sunlight during a solar eclipse in 1868 by Georges Rayet, Captain C.T. Haig, Norman R. Pogson, and Lieutenant John Herschel, and was subsequently confirmed by French astronomer Jules Janssen. Janssen is often jointly credited with detecting the element, along with Norman Lockyer. Janssen recorded the helium spectral line during the solar eclipse of 1868, while Lockyer observed it from Britain. Lockyer was the first to propose that the line was due to a new element, which he named after the Sun. The formal discovery of the element was made in 1895 by chemists Sir William Ramsay, Theodore Cleve, and Niels Abraham Langley, who found helium emanating from the uranium ore, clevite, which is now not regarded as a separate mineral species, but as a variety of uraninite. In 1903, large reserves of helium were found in natural gas fields in parts of the United States, by far the largest supplier of the gas today. Liquid helium is used in cryogenics, its largest single use, consuming about a quarter of production, and in the cooling of superconducting magnets, with its main commercial application in MRI scanners. Helium's other industrial uses, as a pressurizing and purge gas, as a protective atmosphere for arc welding, and in processes such as growing crystal to make silicon wafers, account for half of the gas produced. The small but well-known uses as a lifting gas in balloons and airships. As with any gas whose density differs from that of air, inhaling a small volume of helium temporarily changes the timbre and quality of human voice. In scientific research, the behavior of the two fluid phases of helium-4, helium-I and helium-2, is important to researchers studying quantum mechanics, in particular the property of superfluidity, and to those looking at the phenomena, such as superconductivity, produced in matter near absolute zero. On Earth, it is relatively rare, 5.2 parts per million by volume in the atmosphere. Most terrestrial helium present today is created by the natural radioactive decay of heavy radioactive elements, thorium and uranium. Although there are other examples, as the alpha particles emitted by such decays consist of helium-4 nuclei. This radiogenic helium is trapped with natural gas in concentrations as great as 7% by volume, from which it is extracted commercially by a low-temperature separation process called fractional distillation. Terrestrial helium is a non-renewable resource because once released into the atmosphere, it promptly escapes into space. Its supply is thought to be rapidly diminishing. However, some studies suggest that helium produced deep in the Earth by radioactive decay can collect in natural gas reserves in larger than expected quantities, in some cases, having been released by volcanic activity.